Hello, welcome to BGP Masterclass. Today lab is BGP AS override and BGP Allow AS in. So BGP AS override and BGP Allow AS in. This is the two concept of BGP, which is used for the for example in BGP there is a concept is there when a BGP router receive any prefix, if see that in AS path list it has in own AS number, it discard by default for loop prevention. For example, here is 65,000 AS, and here also 65,000 AS. Both are the same customer only. Okay, but why they are using 65,000 here? Because service provider is given for those customers 65,000. Okay, so for this customer, service provider given the 65,000, you can use the 65,000, so that they are using the both are the 65,000. When this is the R1, R2, R3, R4 and R5. When R5 update come, when R5 update come here, so it will be the router 1C it in the S in that prefix in the S path list, it has own S number. Okay, so it will be the ignore. Okay, so that this the solution is S override and BGP allows AS in. Okay, this is the two solution. So how will we configure this solution and everything will be see. So first we will be go through the little bit theory. So what is so little bit theory. So here the theory is there. Here theory is there. BGP AS override versus BGP allows AN. Okay, BGP allows AN. This can be configured on the customer edge router. Means here only configure. Okay, this configure only customer edge router. What will configure? Will BGP allow AS. Okay, allow AS. This allow AS configure the customer edge router, and BGP override as configure as a service provider router as PE router. Okay, this is the different. Allow AS means in the customer AS will be saying that allow the AS. Okay, and override AS means P edge router. What will be do when receive a same AS number? So service provider, for example, here service provider AS is 100. Okay, so this update will be come here. Okay, update will come. How will you update? For example, this is 5 network for 5 loop back. So update come 5.5.0/24. Okay, /24. Update come. How will be update come? This is the S100. Okay, this is the S100, and this is the 65,000. Okay, this is the 65,000. Okay, this is the 65,000. So normally update like this coming. Okay, but here 65,000 S is there, so it will be ignored, because when a router see in own S number in the S path list, so we ignore. So if configure S override, so what will we do? This PE router remove this S, remove 65,000 and add his own S. Okay, own S means that update come like that 5.5.5./24. 100 and internal update for this. So it will be moved to the, it will change to the 100. Okay, if configure the allow AS in, how will be update will become? Update will come like this. So when configure for here, we configure the allows n, so that update come 5.5.5.5./24. So here coming the S100. Yes, S100. Then here coming the S 65,000 internal. Okay, so like this coming. So if you see here also 65,000, here also 65,000, because we are saying to this router to allow S in. Okay, so this is the concept. How will be configured and everything will be checked one by one step. Maybe this is what we will be do. We will be configure the R2 and R3 and R4 as a MPLS configuration. So MPLS will be configuration, and R1 and R5 is the customer edge router. Okay, customer edge router, and this is the peer edge router. Okay, and this is the P router. Okay, this is the P router, this is the custom peer edge router, and this is the customer edge router, vice versa, same. So what we'll be saying in this allow, inside BGP allow AS in allows and configure in the customer edge router. Okay, just now we will discuss, and it's tell them to accept the prefix their own S number in the S path. Okay. And then S override can be configured at the peer edge router. The S number will be replaced with the S number with the service provider. Okay. Okay, just now we discuss. After that BGP there is a two type of loop prevention mechanism is there. Normally two type of is there. So in eBGP that loop prevention mechanism is the S path attribute. Okay, S path attribute for eBGP S path attribute. S path attribute what saying, if a BGP router receive a prefix with your own S its own S in the list of S path, it's discard the path. So when this is the eBGP, no, so eBGP will be divided. This is a BGP 100, this is BGP 65,000. When a receive a prefix from the eBGP, when see that eBGP for eBGP, if a BGP router receive a prefix with your own S number in the list of S path, it will discard the prefix. Okay, this is the S path attribute. This attribute is used for eBGP. Okay, for iBGP it uses the split horizon rule. What is the split horizon rule? So when update received from the iBGP neighbor, it should not be send the update with the other iBGP neighbor. Okay, this is the split horizon loop prevention mechanism, and this is the iBGP loop prevention mechanism, split horizon rule, and S path attribute is the eBGP loop prevention mechanism. Okay, so now today I will discuss eBGP loop prevention mechanism, S path attribute, that one. So after that eBGP in BGP AS override. What is the BGP AS override? It's allow AS in solution for the BGP router receive a prefix with own S number. Okay, means just now we discussed now BGP AS override and BGP Allow AS. This is the solution for BGP router receive own prefix in the S list. Okay, own prefix. This is the solution for the loop prevention. Okay, for the eBGP solution. Okay, after that. Allow AS in use for the customer edge or CE router. Okay, this is the using for the customer edge router, and AS override using for the this peer edge router or service provider router. Okay, so this is the after that we will be see the configuration. Every configuration will be see how will be configuration step by step, and I will see the output. Okay, by using debug command and see the output of why it not receive and all. Okay, so I'll be very fast. I'll be show the configuration every configuration. First I will be show the R1 configuration, then R2 configuration, then R3 configuration, then R4 configuration. I have already done every configuration. I will be show on one by one. This is the configuration, R1 configuration. R1 what saying? We configure the loopback because we check the connectivity between the R1 and R5. So we configure the one loopback. That loopback advertise in BGP and make a R2 as a eBGP neighbor. Okay. Like that configure R2 side. R2 side is the peer edge router. Peer edge router is a very big configuration. This configuration is the customer edge router. Configuration router nothing. See, another point is I should say both customer are using the BGP only, not any IGP protocol. Okay, both customer are using BGP, so that only we have configured the BGP routing protocol. Okay. Both customers are using BGP, and so if you see here, So only we configure the one loopback and advertise that loopback, and then R2 is the BGP neighbor, that only configure in customer end side. After that R2 configuration little bit length. So in configuration the loopback, because I for the configuration I explain everything to no doubt anything. So that R2 configuration loopback, because of loopback configuration R2 and R4 both the peer router both the peer router R2 and R4, so that it will be using for IBGP peering, using loopback interface, so that we configure the loopback. Okay, so R2 and R4 is the IBGP neighbor and using loopback interface, so that configure. So IPCEF we are enabled for MPLS. Then MPLS this is all the configuration mode we need to do. After that MPLS IP need to enable, because that level will travel in that in that router. After that MPLS level protocol LDP. After that MPLS LDP router ID loopback 0 force. Okay. After that we will be apply the in this interface enable the MPLS IP, this interface service provider side interface, enable the MPLS IP, because that MPLS level will be travel in that interface. After that we configure the OSPF, because we have configured the R in the service provider core network, we configure the OSPF R2, R3, R4, so that we advertise on loopback, because we are reachable each other. After that we advertise direct connected network. Okay, then configure the BGP. Configure the BGP what saying BGP AS 100. After that saying BGP router ID 2.2.2.2. Okay. After that never 4.4 update source loopback is never 4.4.4.4 remote AS 100, and 4.4 is update source loopback 0 and next hop self. Okay, 4.4 next hop self. Why you are configured the next hop self? Because when a BGP router receive a route, is when it that route when advertised to the other IBGP neighbor, normally he is not change the next hop IP address. So when I configure the for in this scenario, when a prefix receive from the BGP in BGP, that when advertised to the IBGP neighbor, so next of IP address will be this one. Okay, by default. So when we configure never 4.4 is next of self. So for this router we configure next of self is next of self. So what will we do? This router will be changed for this network, for this 1.1 network. Next of is the own IP address, R2 IP address. So R4 can reach that IP address. If you configure, if I not configure the next of self, so when for this, when R4 receive the update for the 1.1, so next of will be this interface IP. Okay, when configure the next of self is for this never 4444. So whatever update received from the EBGP update, that will be next of IP address is own IP address. Okay, own IP address. So after that next of self, after that we go to the IPv4. For IPv4 enable IPv4 in this router, enable IPv4. After that this is the BGP MPLS configuration. I need to IPv4 normally used for the customer side, and VPN-v4 is normally used for the VPN core network. Okay, VPN core network. So so this is the both are will be activate. Okay. Both are I will be activate for the in BGP IPv4 and custom and VPN-v4 for this in neighbor. Okay. After that we configure the for the after now here we configure the one BRF name is customer client side. Both side we configure the same BRF only. Here BRF name same, or here also BRF name same. Okay, so configure BR name. RD is RD, give the RD value. Normally ISP side ISP what saying RD means to identify the identify the customer, because I am service provider side multiple thousand of customer is there, so that for identify we are normally what service provider is saying that S number as using the RD number. Okay, so that I am also using the RD number 65,000 colon 1. Okay, and then RT number also same only you are using. Okay, for there is no confusion. Okay, so RD are configure the S number is the RD number, and RT number both are configuration done. Okay, after that we configure the serial interface here. After that here configure the, because this interface we are using for the customer side. Okay, so this interface this interface S1/0, this is the customer side interface. So we apply the IP VRF forwarding, this one. Okay, we apply the VRF on that interface. After that, when you apply the VRF, it that automatically that IP address will be removed. So after that we again IP address configure, and this configuration is for the customer end, for customer side. So what will be saying in BGP in R2, in going to the BGP, go to the customer side, and customer end we are just simply make a eBGP neighbor. Customer 1.2.1 is the eBGP neighbor, and activate. Okay, activate. So how will you IP address given? This is the 1, this is the router 2, this is the router 3. So accordingly IP address router name, this is the 1.2 network, this is the 2.3 network, this is the 3.4 network, this is the 4.5 network. Accordingly I give. Okay, so in this is the customer BGP configuration. So what customer BGP configuration what saying, this is go to the BGP, go to the customer VRF. After that saying the this is the my neighbor remote AS 65,000 and activate. Okay, so this is done in the customer side. Now will be go to the now everything is done. After that we'll go to the R3 configuration. R3 configuration also very simple only, because R3 is the peer router. R3 not configure any BGP router. Okay, only OSPF configuration. So this is the R3 router. So R3 router what saying? So R3 router saying just configure the loopback, and configure the loopback. After that enable the IPCF, MPLS IP, and MPLS level protocol LDP, and MPLS LDP router ID loopback 0. After that we enable this interface and this interface MPLS IP, because that MPLS level will be travel. After that we configure just OSPF. In OSPF saying MPLS LDP auto config. This command used for normally MPLS LDP auto config means it globally enable the MPLS LDP. Okay, after that we can just configure the simply hardcore the BGP OSPF router ID. Okay, OSPF router ID 3.3 as per router loopback interface. After that advertise on loopback and advertise direct connected network, nothing more. Okay, so in R3 very simple configuration, IPCF enable, MPLS IP enable, MPLS LDP level protocol LDP, MPLS level protocol LDP, MPLS LDP router ID, and both interface enable LDP IP, MPLS IP. After that in OSPF configure the direct connected and advertise on loopback, and globally enable the MPLS LDP auto config. Okay, So to now come to the R4. R4 same as R2 only. Just all are discuss already discuss what configuration in R2. So I will be again I will be little saying. So this is the loopback configure in R2 R4. I'm telling about the R4 configuration. So loopback configuration because we make a R2 and R4 loopback interface just like that. See this step now all the MPLS router will be configured, or how many service provider core router, no, all router this will be configured. Okay, this up to here this all are configuration is the same only. Okay, so what configuration enable every router in IPCF, every router is MPLS IP, or every router is MPLS level protocol LDP, every router MPLS router ID as a loopback 0, and enable which core this is the enable the MPLS IP. After that we configure the OSPF advertise loopback and direct connected network. Okay, after that we come to the down here. So here what saying, this is the configuration for core network. Okay, so core network what saying, we hardcode the BGP router ID. After that we can saying the R2 is the IBGP neighbor of. Okay, after that saying the R2 is the next of self. After that we enable the for R2 IPv4, for R2 enable the VPN v4. Okay, after that we come to the for customer VRF. Same VRF we configure, which VRF name is in R2, same VRF configure in R4 also, client side. Okay, VRF name in client side, and same RDRT also configure 65,000:1. Okay, so RDRT both are the configuration only same only. After that we apply the this is the customer side. So 1/1 we have IP VRF forwarding, VRF name. Okay, IP VRF forwarding VRF name, and give the IP address. After that we configure the BGP for the customer side. So customer side, just go to the BGP, then go to the inside the customer VRF in BGP. After address family IPv4 VRF name, then R5 is the BGP neighbor, then R5 is to activate it. Okay, so this is the only this only the R4 configuration. R5 also same configuration as R1 which just create the loopback, because R1 and R5 will be check each other connectivity. After that we configure the BGP and advertise on loopback, and R4 as a BGP neighbor AS 100. Okay, now start the configuration, all the configuration from starting from the router 1. Okay, I already have the configuration everything. See here I open that terminal. See, if you see here all the routers, I only configure the direct connected interface. If I will be show that direct connected, nothing configuration any routing protocol. So IP interface brief. So IP interface, so direct connected only direct connected IP address only configure, nothing anything configuration. If you see here so run session BGP, I'm not configure any routing protocol here, all the routers. Okay, so just we configure the IP address. Now start the configuration, all the routing protocol, and so this is the R1 side. Okay, so starting the configuration. So this is the R1 side, all our configuration. Already I discussed what configuration is there. Okay, this is the R1 side. R1 side done. Now go to the R2 side. R2 side configuration is very length, so that I will be step by step will be configured. Okay, R2 side. Okay, one. Then from here. Okay, R2 side configuration has been done. Now go to the R3 configuration. R3 configuration only IGP protocol. Okay, no BGP here. So R3 configuration has been done. Now configuration peer edge router R4. Oh, sorry. Now configuration is R4. Then configuration the R5. Okay, all configuration has been done. I will be scroll down every configuration. If anyone read again this configuration, will you please read, because I need some time to go. Everything will be update each other router. So this is the this configuration is R1 site configuration. Okay, this configuration is R1 site configuration, and this configuration is R2 site configuration. R2 site configuration is very length. Okay, I will be slowly scroll down. So if anyone read, means read everything. Now will be see the update in R1 and R5. Okay, customer edge router. So we are still not configure any that AS path loop prevention eBGP loop prevention mechanism to over the receive the same update. Okay, as same as number in the S path list. So that now if you are see in R1 and R5 will be find that update. Okay, so now go to the R1. Okay, so IP BGP. So IP BGP, see here not receiving the R5 update. Okay, R5. If you go here, so IP BGP, so IP BGP VRF and so IP route. So IP route. Okay, VRF name. What is the VRF name? Customer side. Okay, VRF name customer side. So if you see here, provider edge router received the R5 update. Okay, but customer side not received the R5 update. Okay, because this is the loop prevention mechanism. When a router receives the own S number in the S path list, it will be ignore the that prefix. Okay, ignore that update. So now will be check. Now will be do the some debugging in R1. What is the problem? Okay, so will be little bit make this screen is length. Okay, so we'll be debugging. If you see here, it's not coming. If you see here, it's coming. For this is the routing table of this customer. Okay, IP so IP route VRF name. So it will be received the 5 dot update, but here not receive the 5 update. Okay, so we'll enable the debugging. Debug IP BGP update. Okay, IP BGP update. This is the command to update for the BGP. Okay, so we are enable the turn on the debugging. Okay, turn on the debugging. Now we'll be clear the BGP session, incoming session. So see the logs, whatever log. Okay, so sorry, clear IP BGP, clear IP BGP star soft in. Okay, in inbound direction, what updates from will be see. Okay, if you see here, for this update denied. Okay, for 5.5 update denied, What is the reason? Due to S path contain own S number. You got my point? Own S path. See, if you see here that after what update saying, this 5.5 network is denied due to S path contain own S number, so that it will be denied. Okay. So and after that we will be resolve search. If you see here same in R4 side also, so IP route, VRF name. Okay. So here also receive the one update. Okay. If you see here R5 show IP route, show IP BGP, it not receive the one update. If enable the debugging here, debug IP BGP update, now debug is on. Okay, debug is on. Now clear the inbound traffic, clear IP BGP star soft inbound traffic. So if you see here same thing, one network denied due to S path contain own S number. Okay. Now both are the same only. So we will be remove. We'll now disable the debug. Okay. You all. Okay. Debug off. Here also will debug off. On debug on debug all. Okay. Now debug all. The debug is off. Okay. So if you see here again, I will be show the output. So IP BGP only see the here one network. Or if you see here, so IP BGP. Here only receive the 5 receive means what? This is the next of 1 means its own network only. Okay, not receive each other update. Okay, here also own network. Okay, so now we'll be do the step by step configuration. We'll be see the update. Okay, see the first to what will be do? First will be configure the Allow AS in the customer edge router. What is the customer? R1 is the customer edge router. Will this open the notepad? Okay, here already I have the configuration, so it will be not down. So so it will be the configuration. This is the configuration AS allows in. What AS allows in will be saying? AS allows saying this, go to the BGP, apply the never IP, allow AS in, the simple command only. Okay, this is this AS allows in is used for is configured in the customer side, and AS override configured in the customer provider edge, service provider side. Okay, P edge router. So first will be configure this command in customer side. Okay, and this is the R1. Okay, the simple command never IP allows AS in. Okay, allow AS in. Okay, the same configuration in R5 also do the same configuration. R5 also same configuration. R5 also saying never IP allows AS in. Okay, go to the R5 configuration, do the same command. Now see the both the router output. So IP BGP. If you see here, is 5 update come and its own AS is accepted. What I am saying, allow AS in. Okay, allow AS in, so that its own AS number. This BGP also AS 65,000 and own AS also it will be received. Okay, in the S path, if you see here in the own S number. Okay, means that update come 65,000 update come from 1 up to 100, then it will become like that. Okay, this is the service provider S number, this is the 5 network S number, this is the update. Okay, this is the update, and will be see the after that will be see the in R5 also same thing. So IP BGP. See, R5 also receive the S update. This is the R1 site update. Okay, R1 side update AS number. Okay, so this will be done. Now will be configure the another attribute BGP AS override. Okay, so this is the two mechanism in in the AS when a BGP router receive a prefix in the AS list, it's showing the own AS number, it will be the ignore by default. So this is the solution to solution override and AS allows in. If you configure the AS override, so how will be update come? This is the 100, again here also 100 will become. Okay, again 100 will become. Another point also I should say, I forget to tell. If you configure the AS allows in, there is a one concept is there BGP. If you see here, go to the BGP. Okay, 65,000. After that, when you configure the allow BGP allows AS in, sorry here. Allows in, after that you give question mark. If you see here 1 to 10 number is there. Okay, 1 means by default is 1. When I give the enter, it will be to take the by default 1. If 2 means what is the up to 10, what up to 10 means, 10 means for example this is very interesting thing. For example, if your S will be come and here, so how many times 65,000 S number will be coming, you should give that one. Here example, here 65,000 one time come. Okay, so that by default is 1. Okay, so that we give an enter. So by default, if this 65,000 in S path coming 2 times, so you should give the never happy allow S in 2. Okay, here give it 2. If this S path is number how many times coming, that number you should give. Okay, so that it will be coming like this. Okay, 1 to 10. Okay, this is very simple only. So in that, if you this 65,000 coming 2 times means you should give the 2, and how many times that this 65,000 coming own S number how many times coming, that number you should give. Okay, so this is the, and now we'll go to the next step, will be AS override. Okay, so AS override, first we will be remove this one because currently we are getting update or each other router update. So remove the BGP configuration. So run session BGP. Okay, config T router BGP no allows AS in. Okay, so this is the configuration, and R5 also this customer side also, customer edge also we remove this configuration. So run session BGP config T no. Okay, so both side remove. Now see the update in R1 and R5 both are show IP BGP. Now we are not receiving. Okay, because that the loop prevention mechanism is applied. Okay, now we will not receive. Now we will go to the next step. This step. Okay, AS override. Okay, this AS override configure in the this peer-edge router service provider side. Okay, peer-edge. Now we will configure the AS override. We will see the update. Okay, so the configuration is here. Go to the R2. Go to the R2. This is the configuration. Very simple configuration. If you I forget to tell this command also, you should know this command also. If you go to the R2, you will see 2 more command. You should this is the troubleshooting command. This command what saying, show IP BGP VPN v4 all summary. This command saying how many neighbors that VPN v4 connectivity is there. So this neighbor is VPN v4 connectivity is there, this neighbor also VPN v4 connectivity is there. Okay, so this is the troubleshooting command when you are configured the customer service provider side. So we will be do this normally with this command. So we will be find that that neighbor is established or not. Okay, the VPN v4 established or not. Another command is this one. This command what saying, this command show IP BGP VPN v4 all show IP VPN v4 all never IP advertise route, means he's saying what route for this number what route provider edge will be advertised. Okay, this command, see if you see this command what saying, see now if you see in R1 this neighbor is not receiving the 5 update. If you see here R2 what saying, he's sending update 5.5.5. okay, whatever never IP advertising route. Okay, so IP BGP VPN v4 all never IP. So this is the troubleshooting command. So if customer side is not receive any route, so the service provider normally using this command, so IP BGP VPN v4 all never IP advertising routes, means this already service provider advertise this route. Okay, because of low prevention that customer has been not received. Okay, so this is also one command we should using this command. So this is the configuration for AS override. This configuration very simple. Go to the service provider BGP. After that, go to the in that BGP, go to the customer BGP. Okay, address family IPv4 BRF name. Okay, after that it will go make a never IP AS override. Simple command only. Okay, configure the in R2 provider edge router, and same configuration and configure in the R4 also. This is the period router. Okay, AS override. Okay, so both are configured. Go to the BGP. After that, go to the customer BGP. After that, we will apply this neighbor is the override. Now, if you see in the BGP, show IP BGP, it will be take little time. Okay, take little time. So now he's come. Okay, so see his 5 dot coming. This is the override means this AS number normally 65,000. Okay, so this number should be 65,000. It's the R2 replaced to the own AS number override. Okay, service provider this override to the own AS number. So it will be coming like this. If you go to the R5 also, so IP BGP, the R1 update coming. This update should be 65,000, and service provider change this update to the service provider this update to the 100 is own AS number. Okay, so now will be done this lab. After that, we check the next step will be check the reachability. Okay, reachability. If you try to check the reachability, there is a some see if you here what happened because for in R5 for to reach the R1 network, next stop is the what 45 network. Okay, this is the 45 network. 45 network means this is the R5. Okay, R5 to reach the R1 network. R5 to reach the R1 network. So this is the network. That's also when R5 send packet to R1. So source IP will be source network will be this one. Okay. So R1 should know this network. Then only it will be reachable. If you come in R1 routing table. If you come in R1 routing table, come here R1 routing table. Show IP route. So IP route here, if you see here 45 network not available, so it will be not reachable. But the thing is that when if you see here so IP R1 5 network is there, no, so you can ping through the loopback, because even R1 side know how to reach the 5 network, okay, 5 network, okay, 5 network, so it will be reached, right? So if you ping here, ping from R1 5.5.5.5 source loopback 0, okay, loopback 0, it's not reachable. Why not reachable? Tell, why it not reachable? Because it should be reachable, no, it should be reachable, no. See, if you ping R1 to R5, because R5 no how to R5 no R1 network, how to reach R1 network, so that we are using the loopback, okay, using the source is a loopback, because R5 know how to reach the source network, okay. So 5 is why not reachable? Because in BGP, service provider side, we configure the OSPF. In the OSPF, there is one concept is there. OSPF, that concept what when configure MPLS VPN using OSPF, okay, period router to period router should be a dedicated link, okay, for the properly routing, okay. So when using the loopback interface OSPF, it should be a P2P connectivity for one-to-one connection. What saying if I will be tell here, in service provider side core network, we are using these two network make as a loopback interface, okay. In that loopback interface reachable by OSPF, right? We configure the OSPF. So these two loopback using the OSPF to the reach the, but in by default in OSPF that loopback is not dedicated, because that loopback is not point to point, okay. So that we need to that loopback point to point, then only there will be routing between each other properly, okay. So so this is the concept. If you want, I will be show that another article here. See this one. See this one, same thing he's saying. This is the when configure the MPLS VPN using OSPF, configure the network type on loopback interface, use periods router. It's the communication point to point, okay, the standard practice, okay. So what he's saying is for point to that loopback it should be point to point, okay. So that you need to configure for the standard practice unit should be point to point to reflect the dedicated one-to-one connection established between the periods router, okay. MPLS backbone establish the efficient routing within the VPN, okay. So it's what saying it's saying these two when configure the in service provider side, when we configure using loopback P2P for this two BGP, when using the loopback to make as neighbor by using OSPF, okay. When you configure the OSPF through OSPF, we make a neighbor using loopback. That OSPF loopback normally not point to point. We should go to that loopback and saying that loopback is to a point to point. Then will be they'll treat like properly. They'll make as a point to dedicated connectivity from this one to this one. So what will be go to the here. Go to the routing protocol and configure and go to the show run interface loopback 0, okay, loopback 0. So config t interface loopback 0. What is the command? IP OSPF network point to point, right? Network point to point, okay. This is the command. So now this two network, now these two network, and go to the R4 side also. R4 side also do the same thing only. Config t interface loopback 0, loopback IP OSPF network point to point, okay, network point to point. Now now these two loopback act as a point to point. Okay, what configure R2 and R4 is now it is like point to point connectivity. If you see here, now if you see here, go to the R1 side again, go to the R1 side. Previously we are not reachable this one, okay, using loopback. Now see, now reachable. Okay, so this is you should remember this one. This is the concept. This is the for the mention. This is the some protocol define these things. Okay, in if you go to the R1 also ping. Okay, ping 1.1.1.1 source loopback 0. Okay, so this should be remember when you configure any service provider side loopback, is that loopback should be point to point. Okay, so now we'll be seeing the another step. We will be see the directly. Now you are using the loopback. Now we will be see the directly, because directly not reachable. Ping 5.5.5.5 is not reachable, because that when R1 send packet to R5, that source network will be 1-2 network. Okay, so R5 so IP route. So IP route that 1-2 network is not available, so it will be denied. Okay, so now we will be configure the now what we will be do a simple thing here. Now also when we packet send packet to R1, that source network will this network. Okay, so so R5 should know this network, then only. So what will we do? We in BGP in customer side we advertise this network. So R5 will know how to reach this network. Vice versa, this network we advertise in this BGP R5. So R1 also know how to reach this network. So we do the same thing only here. Do the same thing here. What will we do? Come to the R1 side and go to the BGP. Now if you see here R5 it will not reachable. Okay, now go to the BGP configuration. So run session BGP. Okay, config T router BGP network 10.0.12.0. okay, mask 255.255.255.0. okay, accordingly same thing here also doing. If you see here show IP route. So now this network know how to reach this network. Okay, if you see ping here ping 1.1.1.1. okay, okay, again it is not reachable. 1 minute. Because why not reachable? Ping 1.1.1 because when is sending the packet for 1.1.1 it will be see here and the router now through 4.5 network. Okay, through 4.5 networks. So R1 don't know how to reach the 4.5 network, so that when is sending the packet via 4.2 network 4.5 network, so R1 don't know how to reach this 4.5 network. If you go to the R1 network, okay, R1 don't know how to reach the 4.5 network, so that it not reachable. It should be advertised first, then only it will be reachable. Okay, so I'll go to the R5. So run session BGP. This is also troubleshoot part. Okay, config T network 10.0. this 5 network is 4.5. Okay, this 5 network, this 4.5 network is the own network. 4.5.0 mask 255.0. Okay, now done. Now check the reachability between the routers. Now you ping the directly for 1.1.1. now reachable. Okay, if you see here 5.5.5 now reachable. So directly also reachable because they know how to reach the source network. Okay, when send R1 packet to R5, so R1 network should be no R5, and when R5 send packet to the R1, so R1 should know the which packets come from the which source network. So now is the reachable each other, both router. Now going to the again briefly the configuration steps. Okay, this is the theory. This is very simple thing, but this is the very useful. Where is the important concept? This is the AS override and allow AS in, both are the concept. This concept normally I will tell everything. So in BGP and this is the BGP AS override and BGP Allow AS in. BGP allows in normally use the customer side, and override normally use AS allow AS use for the customer side, and AS override used in the ISP side. Okay, P-Edge router. And BGP loop prevention mechanism what saying for eBGP AS path attribute what saying eBGP loop prevention mechanism saying if a BGP router receive a prefix with own AS number in the AS list in the AS path, it discard the path. Okay, what eBGP what saying BGP AS path attribute. If when you have to see the prefix in the own AS number in the AS path list, it ignore the path. In iBGP, it does split horizon rule. iBGP what saying the when receive iBGP when receive one update in iBGP neighbor, it should not advertise to the other iBGP neighbor. This is the okay, when order received from the IBGP neighbor, it should not advertise to other IBGP neighbor. Okay, so this is the BGP AS override and allow AS. This is the solution for the BGP router receive a prefix with own AS number in the AS. Own AS number in the AS number. Okay, AS path list. Okay, so this is the solution. So this is the lab. Thank you for watching, and please subscribe our channel BGP Masterclass to watch more videos. Thank you for support, and thank you for watching. Thanks.